Hello, everyone. Welcome to Stat 1220, Elements of Statistics 1. So we've already talked about Section 2.3, Measures of Variability, 2.4, Relative Position of Data, and today we are on 2.5, the Empirical Rule and Chebychev's Theorem. So we will start with Empirical Rule. And this rule is used only for bell-shaped distribution. So what we mean is that if you have a data set and you visualize it and it looks like a bell-shaped, then you can apply this rule on it. So with bell-shaped distributions, we have the median to be the same as what? The mean. So these two measures determine the center of your data set. So we want to create an interval, and this interval we want to believe that approximately some kind of percentage of our data set will be within this interval. So that is the concept of the empirical rule. So how do we do that? We are saying that if we have a bell-shaped distribution, we have two parameters, that is the mean and the standard deviation. So we add the standard deviation to the mean and we subtract the standard deviation from the mean. If we do that, we've gone one standard deviation of the mean. Then we've created some kind of interval. So by the empirical rule, then approximately 68% of our data set will be within this interval. Similarly, if we double this standard deviation and add and subtract, then we create an interval. And we believe that approximately 95% of our data set will be within this interval. If we triple the standard deviation, then we are going to have approximately 99.7% of our data set will be within this interval. Let's demonstrate an example so that we can have a feel of what we are saying. So let's say I have a data set, and in this data set, I have the mean to be 5. So I have mu to be equal to 5, and I have the standard deviation to be 2. So whenever you are given the variance, make sure to take the square root of the variance to get your standard deviation and use this rule. Do not use the variance. You are saying a standard deviation. So we want to create an interval and get to know the percentage, approximate proportion of our data set that is within this interval. So we do one standard deviation of the mean. So what we do is that we subtract 2 from 5, then we add 2 to 5. So by so doing, we create an interval, and this interval gives us 3 and 7. So by the empirical rule, we are saying that 68% of your data will be within this interval. Then if we double this, if we double the standard deviation and add to the mean and subtract from the mean. So if you double the standard deviation, you're getting 4. So 5 minus 4, then 5 plus 4. Then you're going to have an interval of 1 and 9. So we've widened this interval. Oh, sorry. So we've widened this interval. And by the empirical rule, you're saying that 95% of your data set will be within this interval. Okay. If we triple the standard deviation and add and subtract from the mean, then you're going to have 5 minus 6 and 5 plus 6. So by so doing, we are going to get this interval to be, minus 1 and 11. So we further widen the interval, and by the empirical rule, we are saying that 99.7% of our data sets will be within this interval. That is the whole concept of the empirical rule. There's something interesting to also note. Okay. So as we are moving ahead, as we are increasing this interval, we are adding some kind of percentages to the previous percentages. Okay. So for us to understand the diagram here, for us to understand this diagram that I'm circling, okay, then I'll be doing some explanation here. So with the first interval, if you go one standard deviation by the empirical rule, so let's say this is my first interval and I've gone one standard deviation of the mean. So I have 68%. I believe that 68% of my data will be here. If I divide this into two, then I'll be having 34% here and another 34% what here. Okay, if I widen this interval to include more of my data set by the empirical rule, we are saying that we have 95%. We have 95% of our data set here. If you divide this interval into two, then you're going to get what? 47 here, 0.5%, and another 47.5%. If we widen the interval again, and then we are saying that by the empirical rule, so we've gone three standard deviation of the mean, then you're going to have 99.7% of our data set within this interval. If I divide this into two, then I'll be having 49.85% here and another 49.85% here. Okay, so this is the whole concept. But note that at each interval, so within this parts, we've added some proportion to get to what? 47.5%. And the proportion added, or the percentage added, is what? 13.5%. 13.5. So if you add 13.5 here, you're going to get this number. If you add 2.35 here, then you're going to get this. The same thing applies here, here, and so. So that is the meaning of the diagram that you are seeing. Okay. All right, let me clean this. So that is the whole concept. So whenever you have a data set, or whenever you are given the mean or standard deviation, then if you are to find the approximate proportion of data set that will be within this interval, you can draw this diagram. You can draw a sketch of a diagram like that. Okay, let me go here. And so what you first do is that you draw a sketch of the diagram. So for you to look like this, then you locate, let's say this is your mean, okay, and you've gone one standard deviation of this mean, so you believe that 68. So within this interval, you believe that 68% of your data will be here. Okay, if you go to standard deviation, so let's say we are here. If you go to standard deviation, then you'll be having what? Within this interval, yeah, we're going to have 95% of our data. If you go this part, three standard deviation, then you're going to have what? 99.7% of our data set in there. If you further divide this interval again, then within this 68%, if you divide it, then you're going to have 34 here and 34 what there. But since you have 34 here, if you divide this interval, this 95 to, you're going to get what? So from here to this point, you're going to have 47.5. Then you're going to have, within this part, you're going to have 47.5. But remember that we added some percentage to the 34 to get to what? 47.5. And that was what? This percentage. Okay, this interval was added to it to get to it. So this interval, you need to get 13. So you need to get 13.5% of it. So if you add these two together, you get what? This interval. Okay, for you to get, and for the 99.7% too, then you said, we are saying that from this part to this part, we get what? 49.85%. Then from this part to this part to is what? 49.85%. Okay, since we are at 47, then what is the percentage for us to add to get to 49? So that would be this interval. So you have 34 here, you have 13. So what would be the percentage to add here to get to 49? And you're saying that it is 2.35. Okay, so the whole of this. Then that is how we've created what? This interval. Okay, I hope you do understand. Okay, so what I did was just a sketch, and you could have the real meaning here. I wanted to further explain why we have what we have here. Okay, so let's get to answer some examples. Let's get to answer some examples. Okay, so we have some examples to solve, and with these examples, then you're going to use this diagram to solve almost everything. This diagram that you see here. So this diagram will help us solve everything that we need to know, right? So you can have this at the back of your mind so that you can solve any kind of question. Okay. So let's get to see these examples. So we are to find an approximate percentage of data that is between what 2200 and 3100. We've been given the mean and what the standard deviation. So always draw this diagram. Make sure you draw this diagram and locate their percentages, just as we've seen here. But how do we do that? So first of all, locate your mean given in the question. So the mean, locate it. So the mean was what? 2500. So we located it here. Okay. And the standard deviation is 300. Okay. So we are going to go 1, 2, and 3 standard deviations of the mean to create some kind of interval. And with the help of this diagram, you can allocate the percentages in each interval. Okay. So let's come here. Come in. So let's come here. All right. So we located the mean to be what? 2500. Then if you go one standard deviation of the mean, then we add the 300 to the 2500, then you subtract from it. So if you subtract from it, you get 2200. Then if you add, you get what? 28 what? 00. Okay. So we've reached the minimum point of the interval, that is 2200 here. But we have to get to 3100. Then it implies that we need to add another what? Standard deviation to get to what? 3100. So we add another standard deviation to 2800 to this point. All right, so we get to this interval. So this will be our interval of interest. And in this interval, we have 34%, another 34%, and 13.5%. So if you add them up, you're going to get 81.5% of your data within this interval. That's the whole concept. All right. We're going to do same for the next question. So the next question, okay, approximately what percentage of data is above 3100? Since we've already allocated our percentages in this diagram, so with 3100, what is the percentage above it? So this is the percentage above what? 311. So you add it 2.35 and 0.15, and that gives you a 2.5%. Very simple to do. Okay. Then we have the second question with A and B. So we have the mean and the standard deviation. So you locate the mean, always allocate the percentages is something you should have in at the back of your mind so that it can be easy for you to do it. It's very simple. Okay, so we locate the mean from the question. The mean is 800 and the standard deviation is 100. So we create 1, 2, 3 standard deviation from it. So we add and subtract 100 to create one standard deviation of the mean. So we get to 700 here. Then we double the standard deviation. Then we keep on subtracting. So we subtract another 100 from here. You get to 600. We add 100 to 900. We will get to 1000. Then you subtract another standard deviation of 100, we get to 500. Then you add, we get to 00. So the question is saying that approximately what percentage of the data is between what? 900 and 1000. So you realize that we have 900 here, we have 1000 here. So this is the percentage of data points that will be within what? This interval. So it's 13.5%. 13.5%. Okay. Okay, we do the same for question 3. So we have the mean to be 500 and standard deviation to be 20. So what you're going to do is that we draw this bell curve with the percentages associated, then we try to solve the questions asked. Okay, so we locate the mean to be what? 500. Then we have the standard deviation. Okay, so we go 1, 2, 3 standard deviations of the mean. So we add 20 to it to get 520. We subtract 20, 480. Then we subtract another 20, 460, another 20, 440. We add. So we've created those 3 standard deviation of bits, and we allocate the percentages associated. Now we come back to the question. Approximately what percentage of the data is between 440 and 480? So where is 440? So 440 and 480. So there's the interval. So with this interval, you have to add them up. So we have 0.15%, 0.15%, 2.35%, and 13.5%. So you add them up, you're going to get 15.85%. That is that. Then approximately what percentage of data is above what? 540. So this is 540. So this is the percentage above it. This is the percentage above it. So 2.35 and 0.15%. If you add them up, you're going to get 2.5%. All right. So this is the whole concept of the empirical rule. And note that it is used on what? Bell-shaped distributions. Bell-shaped distributions. Okay. Now we are going to the Chebychev's theorem. The Chebychev's theorem. And this is also very, very, very interesting to note. Okay. Okay, now to the Chebychev's theorem. So the Chebychev theorem is used when you don't know the distribution of your data. The distribution of your data is unknown or is skewed. If that happens, you can use the Chebychev theorem to get to know the proportion of your data set that will fall within some kind of K standard deviation of what? Of the mean. So we use the formula at least 1 minus 1 over K squared of the data falls within what? K standard deviation. When K equal to 1, then you have 0% of your data falling between this interval. So normally we start with K greater than 1. Okay, so when K greater than 1, then you can have K to what? 2. This implies that if you put K equal to 2, then you're going to have 1 minus 1 all over 2 squared, and that is 1 minus 1 all over 4. Then that gives you 3 over 4. So by Chebychev, if you go to standard deviation of the mean, then we have at least 3 over 4 of our data falling within that interval. If you go 3 standard deviation, apply the rule, then you're going to have at least 8 over 9 of our data set falling within what? This interval, so on and what? So forth. So the formula is at least. So at most will be the opposite of it. So if at least 3 over 4 of our data set falls within 2 standard deviation of the mean, then you're going to have 1 over 4, at most 1 over 4 of our data sets falling off this interval. It is not within this interval. That is the whole concept of Chebychev theorem. Okay, so let's get to see some examples. Just as we did for the empirical rule, we are going to apply the same thing. So locate the mean, but since you are starting with K equal to 2, then we double what? Our standard deviation. So that because if you go 1, it means that 0% of your data set falls within that interval. So if you double it, you're going to find some kind of percentage of your data set falling within this interval. Okay, so we have the mean to be, so we have our mean to be 2400. If you double the standard deviation and add and subtract, then you're going to get what? 2800 for the upper and 26 and 2000 for the lower. So we want to find at least what percentage of the data is between, note it well, at least. If it is at most, then you can find the at least and take the opposite of it. You can find that at least. So we know the at least. So we'll always find at least. But if they use at most, then take the opposite of it. So you pick the percentage and subtract from what? 100. Pick the percentage and subtract from 100 to get what? The at most. Very simple as that. So we want to find what percentage of our data is between 2000 and 2800. So we create this interval and realize that we have to go to standard deviation of the mean. And by the Chebychev theorem, then you are going to have 3/4 of our data set, at least 3/4 of our data sets between what? This interval. If you convert 3/4 to percentage, then you're going to have at least 75% of our data set is within this interval. You can write at least 3/4 of our data set, or at least 75% of our data set within this interval. Okay, so with the same question, at most. So now you're going to at most. So at most, what percentage of data is below 1800 and above what? 3000. So we are going off this interval. So we can locate 1800, then we can go below, and we can locate 3000 and we can go above it. But since we are well versed with the at least, let's do the at least and take what? The opposite of it. So realize that since we double the interval, we get to 2800. Then we have to triple the interval. We have to triple the standard deviation. If you triple it, if you triple 200 and subtract from 2400, you get to what? You get to this and you get to that. So within this interval, we believe that 8/9 of our data, at least 8/9 of our data set is within this interval. But the question says at most. So subtract 8/9 from 1. Then you're going to get 1/9 of our data set is at most below 1800 or above what? 1800. Okay, so you can convert 1/9 to percentage. We are going to have 11.1% of our data set at most. Use the word at most. It's very important. It's very, very important. At most and at least. Okay, so always, the at least, do the at least and take the opposite of it to get what? The at most. All right, so let's see the other question. Okay, let me clean some others here. I think. Okay, so 2, the same thing. So we have the mean. So they skewed right. So the data set is not bell shape. So if it's unknown or skewed, then you're going to use the Chebychev theorem to get to know the percentage of our data set that will fall within some case standard deviation. Okay, so we have the mean to be 300 and standard deviation to be what? 30. Okay, so we want to find a percentage of data that is between 210 390. So we start with k equal to 2. I said when k equal to 1, then we have 0 proportion. But if you have k equal to 2, then we create some kind of interval or k standard deviation of this mean. So when k equal to 2, we double what? Our standard deviation. So the standard deviation is 30. If you double it, you get 60. So you add 60 to 300 because this is the mean. Then 60 to 300, you get to this 60. Then 300 minus 60, you get to what? 240. Okay, we are still not at 210. So we have to subtract another standard deviation. So we triple it. If you triple it, you get to 210. Then you get to what? 390. So this is the interval that you want. So by Chebychev theorem, if you go 3 standard deviation of the mean, then you're going to have what? 8/9 of your data, at least 8/9. I almost forget the at least, but always bring it. At least 8/9 of your data set falling within this interval. You convert it to percentage, then you are going to have the percentage that you want. Okay, so you said we are going to get what? That is 88.9% of our data falling within this interval. At most, what percentage is below 340? Above what? 360. Okay, so you want to know the percentage below this. So since you know, okay, so we get to this. So here, you first have to find your at least percentage. So always assume that you don't know the at most. After calculating the at least, you can get to know the at most. So the at most would be the opposite of it. So at least you want to find 240 between a percentage, the percentage number of our data sets between 240 and 360, and realize that if you do that, you're going to have what? 2 standard deviations. You're going to have, that is 3/4 of our data sets between what? 240 and what? 360. So what is the offside? That is the at most. So the at most is 1 minus 3/4, and that is 1/4 of our data set will be below 240 and above what? 360. So if you convert 1 over 4 to 2 percentage, you're going to get what? 25%. Or if you have, all right, since we know the percentage to be 100, and you have 3 over 4 converted to percentage, you get 75%. Subtracted from 100, you're going to get 25%. So this is a way to also calculate the percentage number of data set that would be below 240 or above what? 360 used at most. Okay, so at most is the opposite of what? At least. At least we want to find those within. At most, those outside those interval. Always do the one within, that's the at least. Then subtract. If you're asking about at most, subtract it from 100 and you are good to go. Okay, so let's do for always know the question. The questions are very important. Sometimes they can mess them up, can be messed up to trick your understanding. So consider a bell-shaped symmetry. So now we are using a bell shape. So for bell shape, you are saying that if you want to know the approximate percentage of your data set within some kind of interval of the mean, then you're going to use the empirical rule. The empirical rule. If you go one standard deviation, approximately 68% of our data set will be within that interval that you want. Okay, so we are saying about what percentage. So now it shouldn't be at least. So this shouldn't be what? At least. Oh. So about or approximately what percentage, that's what should be used. What percentage of data is between 400 and 500? So first of all, locate your mean. Then, okay, then what deviation should we go? What deviation should we go of the mean to get to the interval that you want? So we want to get to this interval, 400 and 550. So if you add 550 to 500, we get to this part. Then we subtract 50, we get to this part. Then we are settled with the upper bound. Then we realize that we have to go to 400. So we have to subtract another what? 50 to get to 400. So by the empirical rule, we have 34 plus what? 13.5, and that gives us what? 81.5%. 81.5%. So about what percentage of data is above what? 550. So this is 550. And we have what? 13.5, 2.35, and 0.15. That is above what? 550. Add them up, you're going to get what? Approximately what? 16% of the data above it. Okay. Then you do one last example. So always note the question is bell-shaped, so it's circled. So you have a bell-shaped distribution here. Then you are given what? The mean, and you are given the standard deviation. It could be tricked. Sometimes they can give you the variance. Take the square root to get a standard deviation and start applying this. Okay. So we want to find what about what proportion of all deliveries would take between 7.56 and 9.37. So here you add and subtract. So you locate your mean. What is the mean? The mean is 8.46. Okay. Then you add 0.9128. You get to this point. You subtract. You get to this point. So you've created 68% of your data set between this interval. But what interval do you want? You want 7.56. Okay, so realize that if you go one standard deviation, you get to this point below, and one standard deviation above, you get to this point. So we have 68% of our data sets between this interval by the empirical rule. Then we try to solve our last question. Okay. So we are saying that about what percentage of deliveries would take longer than 10.28 minutes. So longer means we should be above it. Okay, we should be above it. So since we've created and allocated these percentages in our graph, we locate where we go do standard deviation. So at this point, we add 0.9128, we get to this point. Okay, so always go 1, 2, 3 standard deviations to get to know all your data values. Then every question being asked, you are going to find the answer there. So you locate this point, then the percentage number of our data set that will be above 10.28 will be 2.35 plus 0.15. Okay, and that gives us about what? 2.5%. So about 2.5% of our data set will be above what? 10.28 minutes. Okay, so that is the end of chapter 2. And in case you are watching this video and you have any further question, if you have any further question, please do not hesitate to email me and I'll be glad to assist you in that, because it entails a lot. That is why I have to break it into 3 sections so that whenever you are watching, you can actually have time to understand each and every section that we've treated. Thank you and see you in chapter 3. All right, bye.